It's Tuesday Geometry. We are going to start with the centers of triangles graphic organizer. So let's see. Let's start with circumcenter. Circumcenter was created by the perpendicular bisectors, and you can see that just by looking at your graph. We've got perpendiculars, and then it's also at the midpoint. So it is the perpendicular bisector. Alright, the circumcenter is equidistant from each of the lengths of the triangle. Now, circumcenter means the circle goes around the outside. It is circumscribed. So circumcenter produces a circle that hits all of the vertices of the triangle. So I know that it's equidistant from each of the vertices of the triangle. Okay. The next one is the incenter, and it is created by the angle bisectors. Now, notice here, like, these are kind of, the lines are kind of split, so it actually keeps going and doesn't split off there. Those other lines are separate.
What is it?
So, circumcenter is, or incenter is created by the angle bisectors. The incenter is equidistant from each of the whats of the triangle. Incenter is where there's a circle inside the triangle. So that's why we have these little ones that are kind of bent off. Because they're the radii of the circle that is inscribed, inscribed. So these are all equidistant from each of the sides of the triangle. So these three radii, MY, MX, and MZ, are all going to be congruent. And actually, I want to go back a step. The radii on the circumcenter ones, MC, MB, and MA, those are all going to be congruent. Alright, then we have centroid. This one is created by the medians. The medians go from the vertex to the midpoint of the opposite side. Okay. A centroid is created by I think it's a segment connected to the
Tell me what the game is called.
midpoint.
Oh. You said it was a scary game.
A segment connected to the midpoint of the opposite side. Nope, it's not segment. We're going to change that to vertex. Because it goes from vertex to midpoint. The fun thing about medians, which is not on here, is these are split into 1/3, 2/3. So we got AM is 2/3 of the whole distance. So AY is 2/3 of AY. And MY is 1/3 of AY. So for example, if AY if AY equals, what did it again? If AY equals 6, split that into 3 equal parts, so there's 2. So we've got 2 here, and then 4 there. So it's 2/3 on one half, and 1/3 on the other. Orthocenter is created by the altitudes. And I like to remember this one because orthocenter is orthodontist, and they make your teeth straight. Well, altitudes are the lines or the segments that are straight from the triangle, especially if you're looking at this BZ one. It's going straight down from the triangle. So orthocenter straight. So a blank is created by a vertex and altitude. That's spelled wrong. Altitude is created by a vertex connected to the opposite side so that it's perpendicular to that side. An altitude is created by a vertex connected to the opposite side so that it's perpendicular to that side. Okay, so those are our 4 measures of center. I highly suggest that you take this document and link it into your TT3 notes. Use the share link up above, link that right in. If not, even take a picture. I don't remember if I already put something in your TT3 notes or not, but link that in, and in just a second we'll go over to the next activity. I've got some sample problems here that I want to go over with you. So taking a look at this triangle, determine first what kind of lines are these? What measure center is this? All right, so this is the in-center. And I know that because there's a circle inside the triangle. In-center, looking back at my notes, is formed by angle bisectors. So what is x? Well, if that's an angle bisector, that means those two halves are the same. So x is going to be 24 degrees. How about this next one? What type of lines? What measure of center? Nothing's perpendicular. It's not altitudes. It's not perpendicular bisectors. So this has got to be medians. It's going from the vertex to the midpoint. So that means we have centroid. And if it's midpoint, then these are split evenly. So A is 7 inches. All right, this last one. This has to be circumcenter because there is a circle. Sorry for the background noise. There's a circle around the outside, circumcenter, circumscribed around the outside. So circumcenter is formed by is it perpendicular bisectors? Yes, perpendicular bisectors. So these little segments are the ones that are perpendicular bisectors. You can kind of tell because they're right angles there. Perpendicular bisectors. So it's not the angle that's bisected here, it's the segment. So these two segments are the same. So x, in this case, is going to be 12 inches. Okay. So your next thing is going to be these task cards. So it's like a modified version of a worksheet. You are free to write on this because it's going to be in a Kami document. And anywhere that says construct, for example, this 1B, we've already done that, so I'm going to take those off. So you're going to write on this, and then you're going to plop your answers in to a Google form. I would like to do this as a Google Meet together. So as soon as you're done watching this video, go ahead and pop into the Google Meet using the banner, and then you guys can start working on this together. I'll just be sitting in there, not paying attention unless you have any questions. So yeah, that's the plan. When you're done watching this, log into the Google Meet. We'll all be in at 10 minutes to the end of class, and this is what we'll be working on for today.